Okay, time to start. Okay, nice meeting you, everyone. This is Sunyanan from IBM Research. I'm a core maintainist from the Kepler Project, and it has been my great pleasure being here to update about our project. Okay, we have a talks and we have several booths in the previous KubeCon, but again, I would like to start about the motivations of the Kepler Project and what the Kepler Project is. The missions of the Kepler Project is basically to answer these questions. How much our energy consumption should be attributed to your workload? This question is not applied to just only the Kubernetes world, but it's also in the process levels, container level, or the pod levels that we are talking. And also, it could be applied to the Baremetal levels, or even the workload that's landing on the cloud. The Kepler project has been initiated or started in February 2022 to answer those questions, to give the solutions by the Red Hat and IBM team, and has been donated to CNCF as a Sandbox project in May 2023. There is three functions that we offer by the Keplers. The first thing is real-time metrics collections. We collect all the resource usage in your machines. We do the second functions, that is 5 grains power modeling. And we do finally we reporting the energy consumptions per process or per container or per pod, like what we call is 5 grains metrics of the energies. And we export it into formats of the Prometheus, which is kind of the factor standard for the metrics, and that can be used to show as a dashboard in the Graphenas, as you can see on the screen. So how do we evaluate or how we values for each functions that we offer? The first one is the real-time metrics collections. Because it's real time, we need something that is lightweight, and we have to make sure that the way that we collect the metrics doesn't affect or making the overhead consume more energy consumptions on your machines. We first looked into the eBPF technologies, as the previous speakers mentioned about the leveraging the eBPF technologies could be solved our first issues. And the second thing is how we do the 5 grains power modelings. It's not simple as how much resource you use, you just have to attribute on that, because the process, container, and pods, they have something shared together. They share some part of the hardware that's consume the energies. It's not straightforward that you can isolate it directly. So during our 3 years, we have a lot of blog posts explaining why we model the power energy in this way. And we also have a lot of the resources in the Kepler website as well that you can track up. And the latest one is the accurate report for the reporting features that we mentioned. So currently, our Kepler's projects community, we are working very hard on delivering the accurate report of the energy consumptions of the workload. This including the effort from the Red Hat team and also the other companies like IBM or Intel, trying to validating the power models, trying to find the benchmarkings, and we are trying to expand the variations of the metrics and the machines to cover as much as possible. We're trying to increase their engagement and contributor to the Kepler project, and we are also considering using the integrations of AI assistant and agents to help things work better. You can also learn more about the Keplers from the many online media. We do the collaborations. We have a podcast with the peer performance. We have the joining the YouTube sessions with very awesome YouTube channels from Whitney and Victor's. And recently, we have got a great honors to be being used and being a part of the awesome tutorials in the Dynatrace YouTube channels, using our Keplers, config our Keplers, and integrate that into the observability platform. So this is all I would like to update today. Please check out these QR codes and reach out to us via the Slack channel, Kepler-project. Thank you.